All right, welcome back. In this video, you can see I've made some changes to the robot, but what we're going to talk about here is how to add that second throttle like I talked about, so you can control the speed of the drive motor and the power of the steering motor separately, in addition to what modifications we should make to the code for that. And then I'll show a useful function that we can use to have this thing do a multi-point turn, so it's able to make a turn in a tight area, how we can simplify that. By defining our own function for it. A few things you'll notice that are different is that I've gone ahead and spent some time mechanically kind of cleaning things up here and getting them attached to the chassis of the car. I just used a couple of zip ties here and some rubber bands. You'll also notice I have a 9-volt battery here with a barrel jack attached to it, which can go into the jack on the Arduino microcontroller here and run the code that we upload to it. So separating ourselves from the USB cable here and having it start to be able to drive on its own, which we'll see at the end there when I demonstrate the pointTurn function. The first thing we'll talk about is how did I add that second throttle, one for the steering and one for the driving. Looking back at our kind of plan here, schematically, you can see some of the images here that we've seen before. We've got the controller, the relay, battery pack, and the two motors, and then our throttle right there. So, quick recap on how this exactly is working. We've got current coming out, on the red wire, goes to the relays and gets routed up into the motors, comes back down, and all the possible places that current can go are connected in parallel with these black wires here. So eventually that has to go up through our transistor before it can return back to the battery supply. So if we clamp down on the current flowing through this transistor, it's basically going to slow down both motors at the same time. What I can do here is split this wire that is between the two motors. So this one, take that out, and essentially take that current up to a second transistor. So I'll just duplicate that real quick here so we can see what that looks like when we wire it up. Okay, so now I have two of these transistors. I put in the 1 kilo ohm resistor, which is there to protect the Arduino from the large battery pack current. The middle leg is our collector, right? So I'm going to have that collect the current that's coming out of this left-hand motor here. So connecting from there on up to that middle leg. Okay, and the right-hand leg is the emitter where the current comes back out of. Where is it heading off to? Well, it needs to head back to the battery pack. And also don't forget, we need to make sure our battery ground is connected to a ground on the Arduino, which is what we have going on down there, just so they both agree on, what 0 voltage is to operate correctly. The, fact here that these are all connected as one line means this is all at the same potential. This is all ground. So I don't need to take my wire here all the way to the battery pack. I can actually just take it over and drop it in that same row there. And it's going to have that pathway straight to the return. It's a little bit easier cable management and how I did it on the car. Last thing that we need is the control pin here, right? The base or gate. I always get those two confused with the different type of transistors. Essentially the one that's going to control how much current can flow through here. So this one on the first is already heading back to one of the pins on the Arduino. We used pin 3 last time. And you can use any of the pulse wave modulated pins or analog pins on the Arduino. So what I've done is moved from pin 3 to pin A1, one of the analog pins, just to free up some more space on the digital input-output pins, mainly because I want to demonstrate how we can easily change that in the code, but also that we're going to be adding some other sensors like ultrasonic distance sensor and servo and bumpers eventually. So we're probably going to want to clean up some of those spots there. So let's take again our output pin or control pin there of the transistor and move it down to another one of those analog pins. Okay, so there we have essentially double setup there. The only difference is we're now routing current coming in from this motor through this left transistor, which is being controlled by analog pin 0. And we still have the original one here, which is collecting current coming from this motor, and that is controlled by analog pin 1 down below on the Arduino. Both their emitters go to ground and are also connected to the ground on the Arduino, just like we need it to be. So let's take a look. What do we want to change in our code now that we've added this second resistor? I think this is where we left the code last time. We had tested this out with a little test function in the loop portion of our code, seeing how changing the value on the throttle pin between 0 and 255 controlled the speed. So this would be full speed at 255 and 0 would be turning it off. Now that we've got 2 throttles, we should probably be more specific about what the throttle pin is. So I'm way up here at the top of the code. And I'm going to have a throttle pin for the steering and for the driving. So let's call this the throttle pin. Let's call it throttle drive pin and make that equal to the original throttle, which I'd moved over to analog pin 1. So A1, redefining that there. Super easy to do if you're good about defining pins up here at the top. I'm just going to copy this, paste it right below, and we'll call this throttle steer pin. And that was in A0 where I plugged it in. Okay, when we used this throttle pin before in the last video, we also had to define its pin mode as an output. So here's throttle pin for driving. And that's now an output, and I also need to have this for the steering one as well. All right. In our loop here, we had put the throttle writing right at the top of the code to set the value there. I'm actually going to take it out from there, out of the test routine, and put it up here at the bottom of our setup function. So before we get into loop, remember these are things that will happen one time. So it's a good, if I don't want to change the throttle after the robot begins doing what it's doing, I might as well just do it one time here instead of calling it over and over again. So analog write the throttle drive pin, and analog write the steering throttle pin. Okay, so with my car, the problem that we had is that I successfully slowed down the driving motor when I set this to a lower value, like 130. But when that 130 value was affecting the steering motor, it didn't have enough power to turn the wheels. So here I'm going to keep that steering throttle set at its full value. Essentially, that'll allow my car to make a really sharp turn and then move slowly, which is exactly what I was hoping to get. If I keep both of these at full speed, the back wheels actually spin out, tries to accelerate too quickly, and this will be a perfect combination of those two things. All right, so one last thing I wanted to show in this video was like a useful example of what this might look like. So switching back to the code here, I'm going to show you a new user-defined function that we can test this with. Let me go ahead and comment out our test function in the loop so that doesn't get in our way in a minute. And I'm going all the way to the bottom, past all of our other user-defined functions. And you can see I've got one here that I wrote, which I called pointTurn. It doesn't return anything when you call it. It just does the operations between its curly brackets. It does take a input. It's a integer, and right now I'm calling it number of turns. So what does this code do? Well, it is going to use a for loop, which if you haven't seen those before in coding, is a structure that will repeat everything between its curly brackets for a certain number of times defined by these conditions. So there's 3 things that the for loop needs to know. It needs to have some counter that you define. In this case, I've defined an integer variable called I and set it equal to 0. So we've got our counter. It needs to know what is the condition that that counter needs to meet in order for the loop to continue to go around and around. In this case, I've said that my counter should be less than the number of turns, right? That's the input I put into this function when I call it. So anytime that's true, it will continue to go through this loop. And the last thing that you put up here is what happens to the counter every time you complete one loop. This little shorthand notation, I++, or really any variable with a plus plus behind it, increases that thing by one whole value. So if it began at 0, goes through the loop, the next time it begins the loop, it's going to increase that by one value. So I becomes 1 second time through. So hopefully that makes sense in that short introduction. If not, Arduino's online reference is really good for remembering the structure of these and how to set them up. Okay, so what is it repeating over and over again? Well, essentially a multi-point turn. Like driving a car, you can do a 3-point turn to turn around in a tight area. That's what this function will do. Turns the wheels to the left, goes forward and stops. Then it turns the wheel hard the other direction to the right and backs up and stops. You do that a bunch of times in a row, your car is eventually going to make a pretty tight turn. So just kind of modeling it here. Turn to the left, go forward, stop, turn to the right, go backwards. Left, forward, right, backwards, right. And so that's useful. Instead of trying to have your car make this big circle of a turn, you can have it kind of pivot where it is and move around that way. To see this in operation, let's use this pointTurn function and call it somewhere up in our code so we can see how it works. I'm going to go all the way up past the loop, and I'm going to go again to the bottom of our setup function here. If I put something at the end here, it's only going to happen one time. So let's call our pointTurn function, which takes an input. How many times do I want to repeat this? Let's try 4 times. All right, so back and forth, total of 4 times, and then it'll stop because I've got nothing happening in the loop right now. Everything in there is commented out. I've already uploaded this code, so we can go ahead and take a look at it real quick. The code is stored on the chip here of the microcontroller. Now, as long as I power that microcontroller, it's going to run this operation. So let's take a look as soon as I plug this in. Cool. So there was 4 operations of that pointTurn function. Helped to pivot my car about 45 degrees to the right. If I want this to run again, I don't need to unplug the power. You do have this little reset button in the corner of the Arduino Uno. I can push that button and it'll start my code again from the beginning. All right, so that gets my car turning to the left, kind of proves how that pointTurn function operates. What if I want it to turn to the right? Well, let's go back down to our user-defined function and make some quick changes here. So instead of just having this be pointTurn, technically it's pointTurn left. So I changed the name there. If I want to pointTurn right, I can use most of this code. I'm just going to copy it and paste that down below. So I've got pointTurn left still here, and now here's another copy of it. I'm going to call this one pointTurn right. And you know, if you haven't driven a car before, this might be a little confusing, but all we really need to do is the direction that we're turning each time. So instead of pointing to the left when we go forward, we'll turn right. And then when we back up, we just need to crank the wheel the other way. Left. Cool. And now I can tell my car to specifically go to the left or to the right up here in the code. Maybe we'll just upload this real quick and do 4 operations one way, a quick delay so we can see it kind of stop for a second, hold it there for a second, and then pointTurn right 4 times, and then it should stop at the end of that. Plug this in and upload it real quick. All right, I'll wait till it's done thinking there. Now it's going the opposite direction. All right, start it from fresh here. I've still got this 9-volt plugged in here, so the Arduino is powered. I'll just reset the code and let it run. Point turn left 4 times. Stop for 1 second. Point turn to the right 4 times and then stop. Cool. Very useful code there. In the next videos, we're going to continue to build off this as we've been doing so far and finally get our robot to be a little bit more intelligent. A couple of the things we're going to add to it are a servo, which is essentially a motor that you can tell it to go to a specific position and it will keep that position, and an ultrasonic distance sensor. We can get this put on our car, have it look left, right, and center, and make some intelligent decisions about which way it wants to go. No longer having to tell the robot how to move every time we want it to move. It'll decide based on the environment that it sees around it.